All right, so we've so far talked about factoring out a UCF, we've talked about factoring by difference of squares, and we've talked about factoring by grouping. Now we're going to get into the real meat and potatoes of sorts of factoring. And before we do that, we're going to do a quick refresher on what we did when we multiplied binomials by binomials. So if I had an example like x minus 4 times x minus 7, like here at the top, remember you're going to take this x and you're going to distribute it to everything in the other binomial. So you're going to have x squared and then minus 7x. And then you do the same thing with the negative 4. You're going to distribute that to everything in the other binomial. So negative 4 times x is minus 4x, and then negative 4 times 7 is a positive 28. So then your final answer, because you can combine these two middle terms, the x squared minus 11x plus 28. Today we're going to talk about how we can go from this to get back to this. We're going to end up with this as an answer. So I'm going to use the same example so that we have a frame of reference to work with. So we're talking about binomial times binomial. There's an acronym, FOIL, for how you would distribute. So the first two terms go together. The outer and inner terms go together to make the middle one, and then the last terms go together to make the last one. We're going to talk about what to do to make these terms go backwards. And we're going to start by looking at our first terms. This is what multiplies into x here. First terms, if it's x squared, there's not a lot of options. It's pretty much just x and x. So I'm going to put 1x in each of these, because x times x gives me x squared, which is what I want. We secondly need to come up with terms that multiply into my last, and our goal is to get those terms to add up to OI. So I sort of like to make a list of things that multiply into positive 28. So, like I know that positive 1 and positive 28 work. Negative 1 and negative 28 work. I know that 2 and 14 work. Negative 2 and negative 14. 7 and 4, and also negative 7 and negative 4. So these are my factors of 28, and since this is positive, my signs are the same. Either both positive or both negative. Then I need to come up with the pair of factors that I just wrote down that adds up to negative 11. So 1 and 28, that adds up to 29. Negative 1 and negative 28, negative 29. 2 plus 14, 16. Negative 2 plus negative 14, negative 16. 7 and 4, that gives me 11. But negative 7 and negative 4, that's my winner. So what I'm going to do is I'm going to put one of those terms in one of those terms in another. So a couple of key notes here. If the sign on that last term is positive, like it was here, your signs will be the same. They'll either both be positive or both be negative. If this was a negative 28 instead of a positive 28, then the numbers would be opposite signs. One will be positive, one will be negative. So I'm going to do a couple of these like this, and then I'm going to talk about a different way that people sometimes think about this, and or just like organize it, I guess, and you can pick how you would like to do it. So if I've got x squared plus 4x plus 4, my first step, what multiplies to x squared? We know that's just x and x. I'm going to go over to my last term here. My last term is 4. It's positive 4, so my signs are the same. My factors are positive 1 and positive 4, negative 1 and negative 4, positive 2, positive 2, negative 2, and negative 2. And I need the sign, the factors that add up to a positive 4. My winner is positive 2 and positive 2. So I'm going to put a plus 2 in each. In my next example, again, I'm going to start at my x squared. X times x gives me x squared. Then I'm going to move over to my last term. I have a positive 6. My factors are positive 6, 1 and 6, negative 1 and negative 6, 2 and 3, negative 2, negative 3, and get an answer of negative 5, 7, negative 7, 5. Put a minus 2 in one, minus 3 in the other. Now, if you have a really strong knowledge of factors and you can kind of just visualize that and you don't need to write out every single factor, that's okay. You don't need to write them out every time. But it helps me if I don't remember all my factors to have a list of them. And over here, again, I start with my x squared. So I'm going to put x and x. And then I'm going to look at my third term, go to negative 24. Now, since it's negative 24, my signs will not be the same. This time I'm going to have opposites. So I could have a positive 1 and a negative 24. Or I could have a negative 1 and a positive 24. I could have a positive 2 and a negative 12, negative 2 and a positive 12. I could have a positive 3 and a negative 8, a negative 3 and a positive 8. I could have a positive 4, negative 6, negative 4, positive 6. And I need the pairing that adds up to 10. So I'm going to go through, no, this gives me negative 10, that almost works. Negative 2 plus 12, that works. Negative 2 plus 12 is a positive 10, so I'm going to put a negative 2 in one, positive 12 in the other. Now, if this method is making sense for you, continue your notes doing this method. Don't even worry about the x method that I'm about to teach. Now, the x method is the same thing, it's just organized a different way. I'm going to erase this part right here, so if you're not quite ready, go ahead and hit pause. So the x method is all the same, but it's just organizes it a different method. Some people prefer it this way. So basically what's going to happen is you're going to make an x. You're going to put your c term, which is your last term here, negative 12 at the top, and you're going to put your b term at the bottom, negative 4, and you are simply just going to come up with a list of factors of negative 12, and then once you get to the ones that add up to negative 4, you can pause. So negative 12, that's a positive and a negative, and you're kind of just going to separate them. So you could have like so negative 12 and has factors of negative 1, positive 12, positive 1, negative 12, positive 2, negative 6, negative 2, positive 6, positive 3, negative 4, negative 3, positive 4. Now I got to come up with the pairing that equals negative 4. So I'm thinking that pairing here is this one here. Now, if you're really good at factors and you sort of like this layout, basically you don't even need to put the set of factors. You could do just that right away. You don't even have to write the rest of them. I just like to have them so that I can see them. And then, so then it's going to be x plus 2, x minus 6. Now you can switch these. You can put the x minus 6 first and the x plus 2 second. That still works. So I do the x method again on this one. I put my c term at the top, negative 30. And I'm going to put my b term at bottom, positive 13. If you are a strong factor, you probably recognize that positive 15 and negative 2 does the trick right away. If that's not something you saw in your process, go ahead and write out your list of factors before you make your decision. So then you're going to have x plus 15, x minus 2. Like I said, you can think about this however you would like. So if you preferred the French way where you just sort of made the list and were on your way, that's fine. If you like this x method where you organize it just a little bit differently, that's fine too. Let's do some examples of this. I'm going to talk through a few with you, and then I'm going to have you do some. There's some of these that are mixed in using a different method, so I want you to be kind of on the lookout for that, or that you have to do a different step first. So you've got a list of rules here. For factoring polynomials when a is 1. First, you have to have 3 terms. If it doesn't have 3 terms, then factoring the way that I just told you is the wrong way. Second, you're going to check for a GCF. So if you can pull something out of all 3 terms, that's what you're going to do. If the leading coefficient is 1, then you can use the reverse FOIL or the X method to create a product. And then if you want to check your answer, you can just multiply them back to see if you get what you started with. So, in example 1, I do have 3 terms. I don't have a GCF, so I can't do anything with that. My leading coefficient is 1, so I can use reverse FOIL or the X method. I like reverse FOIL, so that's the one I'm going to primarily stick with, just because it gives me a little bit more space. But if you like the X, rock it. Okay, so I know that my first term, x squared, things that multiply give me that, x and x. And then look at my third term, negative 63. So since that's negative, my signs are going to be opposite. I'm going to have one positive, one negative. So I know that positive 1 and negative 63 works. I know that negative 1 and positive 63 works. I know that 3 and negative 21 works. I know that negative 3 and positive 21 works. 4 does not work. 5 does not work. 6 does not work. 7 and negative 9. Also negative 7, positive 9. Okay, so I am looking for terms that are going to add up to positive 2. It seems my winner in this case, this one here, negative 7 plus 9, 2. So I'm going to put negative 7 in one, positive 9 in the other. Got that 2 from this middle term here. In example 2, again, my polynomial has 3 terms, so that's good. No GCF. The leading coefficient is 1, so that means I'm going to use reverse FOIL x method. I'll use the x method for this one. If you like reverse FOIL, better do that one. So put my negative 18 here, put my negative 3 here. So I need factors that multiply to negative 18 that add to negative 3. If you're a strong factorer, you'll recognize that negative 6 and positive 3 works well. If that was not something you saw right away, it might be a good idea to write down your other factors and make your decision after. So then, since this is my answer here, I'm going to have a minus 6 and a plus 3. Now, in example 3, the first thing we check for is that the polynomial has 3 terms. If I'm looking at this, this does not have 3 terms. This only has 2 terms. This is actually a difference of squares. This is what we did in 6.4. So remember, I've got 2 things that can be squared here. So a is n squared, and b is 25. I take the square root of each, square root of n squared, and square root of 25, 5. So just a 2, and that's a minus there. I do an n plus 5, and an n minus 5, and I'm on my merry way. In number 4, first thing I check, I have 3 terms. Next thing I check, if I can factor out a GCF, I do. In this case, I have a GCF that I can factor out. All of these have a factor of 4, so I can pull that 4 out. I can't pull a variable out because that 100 is a constant. So I'm just going to rewrite this as 4. 4 divided by 4 is 1. So x squared, 40 divided by 4, that's 10. So I'm going to have 10x. And then 100 divided by 4, that's 25. Right now, you don't know how to factor if the GCF or if the leading coefficient is 1. So it's always a good idea to factor that out. And now from here on out, we're just going to kind of keep this 4 on the side. So now if I look at this piece right here, this piece has a leading coefficient of 1 and is a trinomial. So now I'm just going to kind of keep bringing the 4 down, and I'm going to make my 2 sets of parentheses. And I'm going to look at what's inside the parentheses to make my decision here. So I've got 1x squared. I know x and x multiply that. I'm going to move over here to my positive 25. Since that's a positive, my signs will be the same. Positive 1 and positive 25. Negative 1, negative 25. Positive 5 and positive 5. Or negative 5 and negative 5. I'm looking for a sum of positive 10. There's my winner. X plus 5. X plus 5. Now, the last 4 here, I am just going to give you the answers to them. I would like you to make sure that you know what they are. Alright, here's what I have as answers. If you have this, go ahead and move on to the homework. If this was tricky, maybe raise your hand, we'll get some help for you.